All right, to continue on with talking about rational equations, we're going to be looking at more denominators and looking at the LCD. So when I'm looking at my denominator here, I see that I have an x minus 1, and an x squared minus x. However, the other thing that I see is that this piece right here, I can factor. So if I factor that piece, that's going to turn into, I'm going to take the GCF out, and that's going to turn into x, and then x minus 1. So now I have a combination of the two other GCFs. So my LCD is the product of the smallest values, of the smallest denominators. So I have x times x minus 1. So what does that mean? Well, that means that we are going to multiply my entire problem by x times x minus 1. All right, so when I set this up, I have x times x minus 1 times x plus 2 over x, because I'm going to multiply it to the first piece, and I'm going to multiply it to the second piece. So then I have minus, and we're going to do x times x minus 1 again, times 4 over x minus 1, plus, and then we're going to do the last piece, which is going to be x times x minus 1 times 2 over x times x minus 1, because we factored it. Now, if I multiply the piece by 0, that's just going to still equal 0. So now we're going to look at for the pieces that we can cancel out. So I can cancel out the x's in the first piece, the x minus 1 in the second piece, and the x and the x minus 1 in the third piece. So that's going to leave me with x minus 1 times x plus 2 minus, so that's going to be 4x plus 2 equals 0. So I'm going to multiply these out. That's going to give me x squared plus 2x minus 1x minus 2 minus 4x plus 2 equals 0. So we're obviously going to have a quadratic here. So I have x squared, I have 2x minus 1x minus 4x. So that's going to give me negative 3x. And then I have 2 and negative 2, which is going to equal 0. So I have x squared minus 3x equals 0. Now, we do not have a trinomial here, but I do see that I have a GCF that I can pull out of my problem. So if I pull an x out, that's going to leave me with x minus 3. Okay? So at this point, I can now separate into two separate pieces. So x equals 0 and x minus 3 equals 0. So we're going to add 3 and x equals 3. So we need to test to see if 0 and 3 are both going to work for this particular problem. So I'm going to pull Desmos up so that we can test this out. So I'm going to start with 0. And we have 0 plus 2 divided by 0. Well, right there, we're going to see that it's undefined. 0 is not going to work for us here. All right, so I'm going to go back. I'm just going to finish plugging it in just to make sure that everybody's understanding that it's still undefined as long as one piece is undefined. So we have 0 squared minus 0. And again, it doesn't equal 0. It's undefined, so that's not going to work for us. So if I go back to my problem and I plug in 3 for all of my x's instead. So I have 3 squared here. And that does equal 0. So the only solution that works for this problem is x equals 3. So this 0 right here, this was what we call an extraneous root. So remember in the problem we talked about the fact that extraneous roots earlier occur when we multiply pieces out. They can produce multiple solutions that actually don't work for the problem. So always make sure you check there. All right, so for my next example, so again, I'm looking at what I have in the denominator. So in the denominator, I have x minus 1, I have an x plus 1, and I have an x squared minus 1. So the key for this one is that I can actually factor this bottom part to do the difference of squares. So the difference of squares, remember, is going to be x squared is going to break down to x and x, and 1, the square root of 1 is going to break down to 1. But when we do it, we have to do a plus or a minus. So remember, difference of squares says that I can break them down into two parentheses, positive and negative, and we take the square root of both pieces. Now, with that being said, we now have a combo of the original two. So we have x minus 1 and x minus 1, x plus 1, x plus 1. So my LCD is going to be x minus 1 and x plus 1. So that's what we're going to do. We're going to multiply my whole problem by x minus 1 and x plus 1. So for just a minute, I'm going to make my screen a little bit bigger. All right, so we have, in this problem, we have x minus 1 times x plus 1. And we're going to multiply by that by the first piece. So 2x plus 3 over x minus 1 equals, and then we're going to multiply x minus 1, x plus 1 times 10, and we factored this, so this is going to be x plus 1 times x minus 1 plus, and then I have x minus 1, x plus 1, and I have that being multiplied by 2x minus 3 over x plus 1. So we're looking for the pieces that are going to cancel for each one. So we have x minus 1 in the first piece. We have x plus 1, x plus 1, x minus 1, x minus 1. And the last piece is going to be x minus 1. So that's going to leave us with x plus 1 times 2x plus 3 equals 10, because everything was gone from there, plus x minus 1 times 2x minus 3. So I'm going to multiply everything out. So that's going to be 2x squared plus 3x plus 2x plus 3 equals 10. And then I'm going to multiply again. That's going to be 2x squared minus 3x plus 3. Hold on, I missed a piece here. Let's see. What did I miss? So 2x squared minus 3x minus 2x, then plus 3. There we go. All right, so when I look at this problem, what I'm noticing here is I have a positive 2x and a positive 2x. So if I move one of those over, those are going to cancel. I have a 3x and a 3x, a 2x and a let's back up. Hold on. Those are negatives, so I was mistaken there. So let's go ahead and combine everything together. So 5x plus 3 equals 10 plus, that's going to be 13 minus 5x. All right, so we're going to start solving this equation. So I'm going to subtract 3x over. So 5x equals 10 minus 5x. And I'm going to add 5x over, making that 10x. So I have 10x equals 10. And for this one, x equals 1. And you can plug that in to check to make sure that it works using Desmos. You will confirm that that does work, but I would check just to be sure and make sure there's not a no solution example. All right, so then for this one, something very similar. We have a denominator of 1, but I need to factor this piece. And if I factor this piece, I see that I have a GCF, and that's going to leave me with x plus 3. So in the denominators, I have a 1, I have a x plus 3, and I have an x and an x plus 3. So the LCD for this is going to be a combination of all the products. So we're going to have x and x plus 3. So we're going to go ahead and multiply my entire problem by x times x plus 3. And that's going to be x times x plus 3 times 7 plus x times x plus 3 times x over x plus 3 equals x times x plus 3 times 9, and we did factor the bottom, so that's going to be over x times x plus 3. So the first term doesn't have anything to cancel. The second term I can cancel the x plus 3's, and the last term I can cancel the x and the x plus 3's. So we have 7x times x plus 3, because I'm going to go ahead and multiply that together. Then I have x squared, because I only have an x and an x left, equals 9. So I have 7x squared plus 21x plus x squared equals 9. So at this point, you can see that we have a quadratic forming here. So this is going to be 8x squared plus 21x. And I'm going to move that 9 over to make it minus 9. Now I'm going to do the quadratic formula this time. Remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac. And that's all over 2a. So this is a, b, c. All right, I am also going to pull up Desmos so that I have a calculator on hand when I need to calculate my quadratic piece. So I have x equals negative 21 plus or minus the square root of 21 squared minus 4 times 8 times negative 9. And that's all going to be over 2 times 8. All right, so I'm going to calculate the inside first. So I have 21 squared minus 4 times 8 times negative 9. And I get negative 21 plus or minus the square root of 729 over 16. Now, 729, I believe, is a perfect square. And it is, so I went ahead and checked that. And I have confirmed that with that perfect square, we have negative 21. So x equals negative 21 plus or minus 27 over 16. Now, in order to find our last two answers, we're going to need to confirm those last two answers by splitting them up. One's going to be the plus and one's going to be the minus. So, when I split that up, I'm going to have negative 21 and plus 27 over 16. All right, so I'm going to do negative 21 plus 27. That's going to give me 6. 6 divided by 16. So I can leave it as 0.375, or I can turn it into a fraction. So I have 3 over 8 for my first one. And I'm going to do the same thing. So for this time, I'm going to subtract. So I have negative 21 minus 27. That's going to give me negative 48. Divided by 16, that's going to give me x equals negative 3. And again, I would need to check this to make sure that both of my roots are real roots and they're not extraneous roots. So I'm going to start with negative 3. So negative 3 plus 3 on the bottom, and we can see that that is actually going to be undefined. So there's no way that those two pieces are going to be equal to each other. So now if I do the 3/8, so I'm going to do 3/8, and actually I'm going to go ahead and do the division here. And we're going to have 3/8 again, plus 3. And that should equal the other side, so 9 divided by, so we have 3/8 squared. Let me make sure I get this properly. Set it, and same thing with you when you're setting it up, plus 3 times 3/8. And that does equal, so the correct answer is only going to be the 3 over 8. All right, so for this last example, again, very similar, but we're still going to have to factor. So I wanted to also show you one where the entire bottom is a trinomial that we're going to need to factor. So when we factor this, we're looking at two numbers that multiply to give us negative 15, but then also add to give me negative 2. So when I look at that, that's going to be 3 and 5. And the only way that's going to work is if when added together, the 5 is negative. So I'm left with 1 over 1 plus 3x minus 5 equals 2x over, and my factors are x plus 3 and x minus 5. So when I look at my bottoms, I have a combination for the LCD, and that's going to be x plus 3 times x minus 5. So I'm going to need to multiply my entire problem times x plus 3 times x minus 5. So I'm going to do x plus 3 times x minus 5. Technically, that's times 1. It's not going to change anything, but I'm still going to write it. Then I have x plus 3 again times x minus 5. And we're going to multiply that by 3 over x minus 5 equals. And then we have x plus 3 times x minus 5. I'm running out of room, so I'm writing a little bit smaller. Times 2x over x plus 3 over x minus 5. All right, so we're going to start canceling out what we have in common. So they have x minus 5 in common. There was nothing in common in the top and the bottom of the first term. But then we can cancel out x plus 3 and x minus 5s. So we're left with x plus 3 times x minus 5. Then we're going to be left with 3 times x plus 3 equals, and then the only thing on the other side is going to be 2x. So we're going to multiply everything out and simplify. And that's going to give me x squared minus 5x plus 3x minus 15 plus 3x plus 9 equals 2x. And I can see that I am going to have a quadratic here. I'm going to need to combine some like terms. So I have x squared. So I have negative 5x, 3x, and 3x. That's going to be plus x. And then I have negative 15 plus 9. So that's going to give me negative 6 equals 2x. And then I'm going to subtract that 2x over. Because when we have a quadratic, we want it equal to 0. So we have 2x minus x minus 6 equals 0. So I'm going to try to factor it. You can use the quadratic if you want, but I'm going to need two numbers that multiply to give me negative 6, but add to give me negative 1. So most likely it's going to be 2 and 3, and that will work with positive 2 and negative 3. So x plus 2 equals 0, so x equals negative 2. X minus 3 equals 0, so x equals positive 3. All right, so I'm going to need to test those out. So we have 1 plus 3 divided by, and we're going to start, I'm going to do negative 2 minus 5. And that should equal the other side. So we're going to have 2 times negative 2 in the top. And then in the bottom, we have negative 2 squared minus 2 times negative 2 minus 15. And that does equal that problem. So each side equals each other. So now we're going to try positive 3. So I'm going to go back everywhere I put negative 2, I'm going to put in positive 3. And check that those two sides are equal to each other once again. And they are. So this one actually has two solutions. So we have negative 2 and we have positive 3. So the key here is to find your LCD. Anything that can be factored, go ahead and factor it in the denominator so you can find common terms. So you make sure you can find the LCD. And then go ahead and multiply it out and make sure you check for extraneous roots.